Good morning, class of EECE392. My name is Raha Darvishi.
My name is Andrea Maji.
My name is Rushad Agarwal.
My name is Dipankar Dawari.
And today my team members and I will present to you how solar energy is used to improve the voltage profile, to power grid-tied communities, and to operate independently as an off-grid system. Renewable energy sources are natural resources that come from the earth. Water, sun, wind, geothermal, tidal, and biomass are common forms of renewable energy sources. Different alternative sources of energy have different ways of generating electricity. For example, solar power systems generate electricity only when the sun shines. Fossil fuel burning plants and nuclear reactors can be operated at any time. Wind power systems can also be operated at any time, but of course only when there's sufficient wind. We often tend to think that BC is not a good place for a solar energy system because of the weather. However, as shown in this graph here, the average daily solar potential in Vancouver is only slightly less than that of Miami. According to Natural Resources Canada, in Vancouver we expect about 5.2 kilowatt-hour per meter squared on a surface that is perpendicular to the direction of sun's light. This is due to atmospheric absorption and cloud cover. When a solar panel array is connected to a battery system, it can produce all the power that a household requires. This alternative source of energy is sustainable, and it also eliminates the need for an expensive electricity distribution grid. The exact amount of power that one can get from a rooftop-style solar power system depends on the size of the solar modules and the amount of solar radiation that it receives. Estimating the amount of solar insolation is a multifaceted process with many factors to consider. Values of insolation on rooftops are dependent on the location, the time of the year, weather conditions, shading from adjacent structures and trees, shading from overhanging vegetation, and the angle of the roof. So why are solar panels such an effective choice when it comes to an alternative source of energy? How do these solar panels actually generate electricity? Well, solar panels work by using the technology of photovoltaic cells to convert solar energy into electrical power. PV cells, also known as solar cells, are the main foundation of the photovoltaic system. A solar cell is an electrical device that converts the energy of light directly into electricity through the photovoltaic effect. These electrical devices can be very small or as large as several inches across. When many of these cells are connected together, they form modules which can constitute solar arrays. So as previously mentioned, this technology relies on the photovoltaic effect. The photovoltaic effect is the creation of voltage or electric current in a material as a result of exposure to light. When sunlight is incident on the surface of a panel, the electrons in the valence band absorb this energy and become excited. Due to this increase in energy, the electrons break free and become part of the current in an electrical circuit. Thus, the photons of light that cause electrons to reach a higher state of energy create electricity. Solar panels produce power by collecting sunlight on the surface of a panel, such as the one shown here. Solar panels are composed of semiconductors, usually of silicon alloys, which is what this solar panel is composed of. Because solar electric systems are modular, we are provided with the option of starting small and increasing our electrical power according to our power requirements simply by adding more modules. In general, the larger the area of the modules, the greater the amount of electricity produced.
Sure.
To illustrate further, the particles in sunlight called photons shine on this dark silicon surface here. These photons drive off electrons that are then captured in this aluminum wire here, creating current that runs through the panel. Each of these panels is wired into an inverter that converts the power from DC current into AC current. This power can either be used immediately with a grid entity or to store in a battery for future use. Most of the systems installed are grid tie and fall under the BC Hydro net metering program. This means that the generated power is fed into the BC Hydro grid for credit when the power is not being used at a particular house or office. A rather significant shortcoming in using solar systems is the incapability of storing electricity at higher efficiencies. Batteries are used to store electricity in remote off-grid locations. For an on-grid system, excess energy is often fed back to the local utility. The lack of adequate storage technology means that during the night or at times of limited solar radiation, solar systems can be greatly ineffective and depend quite significantly on backup energy systems.
Solar energy can be used directly in the distribution system of the electric power system. The distribution system is the last stage of the power system, and it provides power directly to the consumer. It steps the voltage down from 138 kilovolts to 12.5 kilovolts with a step-down transformer. Because there are multiple loads on the feeder, the voltage drop due to the impedance of the transmission line is highest at the last load. The voltage profile is a graphical representation that shows this voltage drop. According to the American National Standard Institute, there is a tolerance of 5% voltage drop. This means that the voltage cannot dip below 0.95 per unit or rise above 1.05 per unit anywhere on the distribution line. Currently, there are 3 main voltage compensation techniques being deployed.
Don't say sorry.
Currently, there are 3 main voltage compensation techniques used to maintain the voltage profile. Load tap changes can be installed on the distribution transformer to change the number of turns on the winding. Voltage regulators can be installed on the distribution substation to keep a constant voltage no matter the power at the generator. Finally, shunt capacitors can be used to improve the power factor, adding reactive power to the load, maintaining a stable voltage. As shown on this graph, the voltage at load B without any compensation has dipped below 0.95 per unit, down to past 115 volts. However, when we add a shunt capacitor on load B, we increase the voltage to be at least 0.95 per unit. The placement of the capacitor bank is extremely important in minimizing the voltage drop along the feeder. The optimal placement for the capacitor is 2/3 down the distribution line. Currently, BC Hydro uses shunt capacitors to maintain the voltage profile for British Columbia. However, problems with capacitors include harmonic resonance, high switching transients due to discharging and charging of the capacitors, and over-voltages. To accommodate for these problems, BC Hydro has to install protective devices as well as the capacitor banks, which increases the cost. By installing photovoltaic cells with a capacity of 2 to 50 megawatts, real power is added to the distribution line, which improves the voltage profile. In addition, photovoltaic units are clean energy sources, which reduces the amount of energy supplied by the generator, which may not be a renewable resource. Photovoltaic cells are also economically beneficial because they decrease the amount of power needed from the main generator due to the independent power producer supplying real power to the load. We have shown through Power World simulations 3 different scenarios for the voltage profile. First, there is no compensation. Second, we have installed shunt capacitors. Third, we have installed photovoltaic cells to replace the shunt capacitors. For each of these scenarios, the parameters of the slack bus of 138 kilovolts of the generator is the same. There is a step-down transformer from 138 kilovolts to 12.47 kilovolts. 4 loads of 2.5 megawatts with a 0.9 power factor are installed, and the transmission line is a length of 10 kilometers with a reactance of 0.4 per unit and a resistance of 0.6 per unit. The case for no compensation can clearly show that there is need for compensation as the first load has already decreased to 0.81 per unit. Installing a shunt capacitor of 25 megabars on load 2 has improved the voltage profile drastically, with a dip of only 0.82 per unit on the last load. More interestingly is the case study of the photovoltaic cell of only 5 megawatts real power installed on load 3. we can see that none of the 4 loads dip below 0.95 per unit, which has maintained the voltage profile.
So in the last 10 minutes, we learned what a photovoltaic cell is and how it works. We also discussed one of the uses of this alternate energy source, how they can be used as a voltage compensator. Another way in which our community can benefit from this source is through grid-tied and off-grid solar power systems. So what is a grid-tied system? A grid-tied system routes your solar panels to the main grid, which allows you to consume your own generated solar energy. It also allows you to sell excess generated solar power to the grid and receive a credit for exporting this power. It also allows you to purchase electricity from the grid when you're running low. One program that encourages the generation of clean energy from renewable sources like this is the microgrid program, which the Canadian government has implemented in Ontario. The microgrid program is designed specifically to encourage the development of micro-scale renewable energy projects, such as residential solar PV installations. As a homeowner or a farmer or a small business owner, you have the opportunity to develop a small or micro renewable electricity generation system. Projects eligible for microgrid have a generating capacity of 10 kilowatts or less. Under this program, you will be guaranteed $0.39 per kilowatt hour for all the electricity your project produces for at least the next 20 years. Now, I don't really need to preach the benefits of using renewable sources of energy. I think Raha covered that pretty well. But there are other benefits to using such a system as well. Firstly, and most importantly, it is economically viable, especially for Canadian and British Columbia communities. On average, total recovery of costs can be expected in 5 to 6 years, which is much sooner than its lifespan of 20 to 25 years. Also, distributed generation requires less distribution and therefore drastically reduces power losses. So on the whole, it is more efficient as well. On the other hand, a grid-tied system has shortfalls as well. Unfortunately, the grid-tied system does not provide outage protection. So when the utility grid fails, these systems cannot operate by themselves. Another issue is that it cannot cater to geographically inaccessible sites, since there is very high interconnection costs, which would make it financially unfeasible. Which brings us very neatly into our next topic of off-grid systems, which is especially important in Canada. So what is an off-grid system? An off-grid system or an off-grid community in North America is a community that is neither connected to the North American electrical grid nor to the piped natural gas network. Canada has about 175 Aboriginal and Northern off-grid communities. Therefore, it is of utmost importance that we do this analysis. These communities operate independently from the grid. The major difference between a grid-tied system and an off-grid system is that an off-grid system includes a battery bank, which allows for total disconnection from the grid. This is especially important and will be discussed in detail by Dipankar later on in this presentation. One company that encourages the usage of standalone off-grid systems is the Dandelion Renewables, which is situated in Alberta. The current market prices the levelized cost of off-grid photovoltaic energy at $0.11 per kilowatt hour, which is on par with recent retail costs of grid power in Alberta. In addition, there is the costs for distribution and transmission that a photovoltaic system helps to avoid. A combination of constantly falling photovoltaic system costs, increasing power prices, a recent increase in distribution charges makes a photovoltaic technology competitive and affordable in the Alberta power market. And this can be extended to British Columbian markets as well. So the benefits of having an off-grid system is that it's financially viable for sites with high interconnection costs, as is the case with 21 out of the 25 Aboriginal communities that currently exist in British Columbia. Another advantage is that no utility bill exists for these power systems, because the owners are completely independent of commodity price spikes and transmission upgrades in the future. One possible setback for this system is that it is more expensive than a grid-tied solar power or utility power system due to the cost of the battery bank, charge controllers, and limited battery efficiency. Hi,
I'm going to be talking about solar energy storage systems. The basic definition of an energy storage system is a physical media that can accumulate energy for later use to perform a useful operation. Our focus for the presentation revolves around the functioning of energy storage system with respect to solar energy. Usually, solar energy storage system is used in off-grid applications which are crucial in remote areas where access to the primary grid is very limited. The energy storage system for voltage compensation could be modeled in a way that instead of returning excess power to the utility, our system will have the capability to store it, and in the event that the solar energy production falls short, our system will draw power from the batteries to offset the required voltage difference. The three main components of energy storage system ecosystem are charge control, battery, and lastly, the inverter. As you can see here, an off-grid system has been shown. The charge control limits the rate at which electric current is either added or drawn from the batteries, thereby preventing overcharging and deep charging that can impact batteries' lifespan. Secondly, the battery. It is a container consisting of one or more cells in which chemical energy is converted into electricity and used as a source of power. In our presentation, we will talk about lithium polymer batteries which are used in residential applications, but more on that later. Lastly, the inverter. It is an apparatus that converts direct current into alternating current. So what makes a good energy storage system? Reliable in use and easy to operate, maintain and service. The battery should be sealed. That is, there should be no leakages which may cause havoc. The battery or physical storage media should have efficient charge and discharge rates, and the entire system should be cost effective. So here's a little overview of lithium polymer batteries. The lithium polymer batteries are rechargeable and are composed of several secondary cells in parallel to increase the discharge current capability, and are often available in series packs to increase the total available voltage. Inherently, they are an evolved version of the lithium-ion batteries with improvements. So, what are the advantages and disadvantages of this battery? To name a few, it reduces dependency upon generator which run on diesel fuel, which is a conventional source of energy. It maintains power quality. It is easy to install. Remote monitoring is remote monitoring system allows control from any location. Backup power during failure of AC input is also doable. Some disadvantages. It is expensive. There are safety issues concerning overcharging and overheating of batteries that can cause fire. Poorly manufactured batteries can develop internal shorts or contamination, causing serious problems. Ultimately, the selection of a battery is very crucial for the energy storage system. It should be appropriated in accordance with technical as well as economic considerations. In the last 20 minutes, we have seen the capabilities of photovoltaic cells as renewable resources. They are a practical option for voltage compensation in distribution systems for DC. They are also economically feasible and efficient replacements for the diesel generators that the off-grid Aboriginal communities in Canada currently use.
Thank you very much for listening to our presentation.